Yeah, so the basic idea behind this was to sort of have kind of combine maybe a Harvard X semi-workshop with a sort of exit talk, and I'm recording it so people who normally come to research meeting can see it. So I'm kind of talking to you guys, plus also a general kind of goodbye research talk. So I always do my standard disclaimer before talk that I'm originally from Trinidad and Tobago, and I have to tell everyone because if anyone in the audience doesn't know that, they say they missed the first part of the talk trying to guess where I'm from, and then they have no idea what's going on. So this is a kind of it's a mixture of sort of what I gave as my faculty interview job talk and some more kind of focus on recent directions. And my kind of goal here is to, I think, show the kinds of things that I've been up to, but also where I'm going next. And I think many of you at Harvard X will be able to see, some of you have been involved in these projects, but a lot of you will see the influence of the great insight I've got from being able to speak to many of you throughout the years. So just kind of stuff, I want to say, it was actually great to be here. 3 years passed very quickly. And my first year was in Harvard X, second 2 years in VPAR research, but I always really appreciated the incredible knowledge that I was able to get just by walking up to a course team member and ask questions. I know, talking with Maggie about China X, something about explanations in that context. Colin is always the go-to person for being able to run anything kind of technical confusing. Drew not only bugs me about pre-course surveys, but has also beaten it squash and given me insights. Luis basically fixed a gigantic problem we had with the app we built in Safari, so thanks a lot for that. And Sam and Sarah, Sarah actually helped me teach my first piece of a MOOC. It was a great baby step. I got to teach 1 week of a MOOC. We did already written a script and modified it. So Sarah, thanks for being such an amazing project manager in that. Oh yeah, sure. And now Sam actually and Sarah, we're actually going to pilot one of the things that I've done here in Canvas. My first kind of external collaboration from NUS or National University of Singapore will be actually trying it out in a MOOC. It's an app for basically dynamically letting students generate explanations and then giving them to future students. Andrew has been involved, especially in already programming for future directions as a data engineer. And MOOClets, basically, Andrew, you guys have been talking MOOClets for a while, right? It's totally evolved. Andrew is the first human being in the world to make MOOClets into an app. So thanks, Andrew, for that. And Jonathan, I appreciate all the conversations about assessment. And Vicky, I know we met recently, but thanks for taking over pre-course surveys. Shilpa is also the amazing technical lead who's always, when I have an issue, want to discuss things. And also my company, because Shilpa is the latest working person at Harvard X. And Ilya's been a great office mate for the past year. So thanks for all the liming and hanging out and working on different projects. So thanks everyone for coming. So I'll kind of dive into kind of more formal part of the talk. And I basically took a 55-minute talk and I'm trying to condense it into 30 minutes. So I'm gonna blaze through a lot of things, but it's just to get a sense. Don't feel like you're missing anything. You can just kind of sit back and let it waft over you and choose 1 or 2 things you want to keep track of. So, and just to kind of give some context, so National University of Singapore, I had never been to Singapore in my life. I actually knew nothing about Singapore, but I went on an interview there, and then I did a second visit before I decided because it was such a big move. But what really convinced me is that even though it's hard to move far away from everyone, is that they've actually got a sort of unique opportunity where they're a large university in Singapore, one of the flagship universities, 40,000 students. And they have a lot of teaching track faculty. So they're not adjunct, they're actually permanent teaching track. And so there's a huge opportunity to work with them to sort of run experiments in real-world courses, on campus, with 40,000 students. And they've also got a huge amount of expertise in School of Computing in terms of applying algorithms, psychology department, and Singapore's sort of big in education in general. So there's a huge amount of government support and funding for kind of taking research we all do here and deploying it out in the real world. So that's the biggest draw to me, So I'll be in the Department of Information Systems Analytics, which is inside the School of Computing. I'll basically be doing a lot of human-computer interaction research, other kinds of things you've seen me do so far. And there's a link here to see the talks. That's linked to slides and recording if anyone wants to see it later. And actually, so one thing in NUS is there's a brand new institute. It's called AllSet. So Institute for the Application of Learning Sciences and Educational Technology. So they've just started out, so they're a lot smaller than BPAR research. But they've got a similar kind of mission, except more on the research side, which is how do we actually take all of the research that's being done and bring it into classrooms? How do we get instructors to teach differently? How do we help K-12 teachers to run experiments? So they're kind of combining all the data across campus and MOOCs. So I'm going to be one of the faculty who's affiliated with that. So my appointment's here, but they're sort of a campus-wide institute. And again, it's going to be fantastic to move there because now I've actually had the experience of being in Harvard BPAL and being able to kind of see what we can carry over. And I'm sure there'll be lots of great collaborations in the future. Just one thing, if you know anyone actually who's interested, we're going to hold a workshop July 9th to 21st, and we're going to do it all online so people can watch recordings or check it out. But it's going to be basically about what kind of opportunities there are for doing edtech research in Singapore at these universities and connecting with collaborators abroad. And there's also actually, I've got funding for postdocs, so we're going to advertise it soon. But if you know anyone who's interested in doing the kind of work I'm about to present, then please let me know or tell them to come be in touch. And they've also got a kind of visiting grad student program. So if you know people who want to do this work and want to come for a summer, and like in the week they work hard and we run lots of experiments, on the weekend they fly to Vietnam or Indonesia, they'll have like a great mix of it. We've just got a huge capacity for like deploying systems into the real world. So please feel free to let people know. Cool. So in terms of my talk, I'm going to really be thinking about how can we deploy resources to the real world and then keep improving them through experimentation. So everyone's aware that these digital resources are just increasing use in education, whether it's K-12 online homework, like Khan Academy Assistance, on-campus courses like Canvas, or massive open courses or MOOCs. One thing I focused on is really a building block of every course, which is the problems that we give students to help them apply their knowledge. And to give an example of a challenge that's faced, imagine instructor Joe who's teaching statistics in edX. Sarah knows one of these people. They give a problem and someone types an answer. But often students don't really understand, they can type this and get it right, but they don't really understand why they're doing it or how it's working. So how can Joe take his problems and supercharge them? Really help students reflect and learn more effectively. And it's not just in math. So here's another kind of problem I've worked on. If you think of Samantha, the clinical psychologist, who's trying to help people learn cognitive behavior therapy to deal with depression, she might give them scenarios like have them reflect on how they could apply cognitive behavior therapy principles for dealing with feelings like sadness or anxiety. But again, how can she make this problem be something that really ensures that someone's getting the concept and applying it to everyday life? So here are kind of two examples of how problems really are building blocks that help people to learn anything. And I think a big challenge is that we can put a lot of these resources out there, but the resources for learning always need improvement. And so when people actually do studies, it's all too frequent that online resources, in-person classes don't actually lead to measurable learning the way you think. And I don't think this is because people aren't producing excellent content or people aren't excellent instructional designers. I think this is just a classic problem that until you actually deploy something out in the real world and see whether the particular design decisions you made worked, you don't always know who it's going to help or how it's going to work. And so what we really need is what's common in human-computer interaction and software development is we design something, high-quality design, but we deploy it to the world in a way that even after it goes out and learners are using it, we can continually implement it, evaluate, and do this cycle of improvement. So instead of just building a really nice course and putting it out, we build courses where their components that are perpetually improving. They never stop improving. And so this, I think, the vision I have is really that I want to build systems that will perpetually improve just like real teachers. So when you make a math problem and put it out online, how do you kind of get it to keep changing? Because if you think about it, if a student is solving a problem and they get an explanation, that's going to help them learn. But if you were teaching someone, you're going to give the same explanation to 1,000 people in a row. Just organically, you explain one way to someone, one way to another person. And that allows you over time to figure out which explanations help students or which explanations help students with different profiles, like different levels of knowledge. So how can we kind of realize this sort of vision for digital resources? So my approach is really all about online experimentation. So I really want to rethink how we do randomized experiments. And you've heard a lot about A/B testing, like in industry or companies like Google. But experiments have a very long tradition in science, whether it's psychology lab studies, educational field experiments in classrooms, or medical trials. And there are many obstacles and challenges to doing experiments. So my approach to rethinking experimentation so that it drives perpetually improving systems is to imagine how do we make experiments collaborative, dynamic, and personalized. So I draw here on my background that's at the intersection of human-computer interaction and education, which is made up of several disciplines. So let's say I want to run an experiment. For example, trying to get better explanations in a math problem, or motivation emails you want to send. In terms of deciding what these conditions are and how we even measure learning, that's where I draw my PhD in cognitive science. I also bridge that with my work in instructional design, like my postdoctoral work at Stanford, as well as work here. where we draw on educational perspectives in deciding what are these conditions, how do we measure learning. But now, how can we actually run an experiment and use data in real time to lead to improvements, product improvement that actually is going to help learners? So I aim to do dynamic analysis, where as we're figuring out what's helping people, we might start off experimenting 50-50, but we can actually change things so that as we're getting data that one condition is better than another, we can change that to 60-40 or 80-20. So you're continually rolling out what's working well. In the end, that can lead to enhancement, where people can get one less condition. But especially if you build the infrastructure just right, like how Andrew did with MOOClets, you also get personalization, where different conditions could go to different people based on characteristics like knowledge or attitudes. To achieve that, here's where I draw my PhD work in Bayesian statistics and machine learning. And I used to apply that to modeling psychology, like how people think. But in the last few years, I've especially focused on how to use Bayesian statistics and machine learning to run these dynamic experiments so that we're analyzing data in real time and constantly rolling out the best. Now, finally, to really go from experimentation with a few conditions to a dynamically improving system, what we have to do is continually add new conditions. In a way, you never stop experimenting. Every time an course has a new idea, every time a researcher has an opportunity to work on something, you can add in new conditions. And to do that, what I draw on is my work in human interaction, especially crowdsourcing and human computation, where you can actually harness learners themselves or instructors and scientists to come up with new conditions. But to enable all of this, to implement a simple experiment in a way that you basically get this collaborative, dynamic, personalized approach, I've developed this software requirement specification. So if you can run an experiment, I would just say, try doing it as a MOOClet, because that will basically guarantee that even if you want to start simple, at any point in time, you're going to have data structures and APIs so that you can actually start doing all these other things, adding new conditions, plugging machine learning algorithms. So to give you a bit of an overview, I started this vision of perpetually improving systems. And the approach, collaborative, dynamic, personalized experimentation. And so I'm going to really speed through just a couple of quick examples, applying this to collaboration between instructors and psychologists on motivation, reflection, and math problems, to a system, actually, the adaptive explanation improvement system, that harnessed explanations from learners and tried to choose the best, which helped learning as much as getting explanations from a real instructor. Close with one simple example of how we can use experiments to how to personalize, and then spend 5 to 10 minutes on future directions, which is really what I think many of you might be interested in, what I'm kind of moving to next at NUS and in continued collaborations with deeper research and others. So one will be bridging instructors, social behavioral scientists, and machine learning researchers. Another is thinking about apps for helping students set goals and do study strategies. And then again, thinking of how we can push MOOClets and keep developing them in interesting ways. So we can do experimentation, and especially bridge from experiments to actually adaptive personalization, like the kind of projects that Ilya and Miguel and others are running and Colin, where you kind of make an entire course adaptive. You can use MOOClets as a backend, and it's a way of blending in experimentation with adaptation. So the context here was running experiments on math problems, where I want to take a math problem and think of how do we add motivation messages to encourage people, or how do we prompt people to reflect so that they gain more knowledge. So one of the first studies I ran before I was at Stanford or Harvard and had access to MOOCs was actually in collaboration with Khan Academy, where we wanted to have a very simple addition, technically, to add motivational messages, where we added growth mindset messages like, remember, the more you practice, the smarter you become. And we compared that to practice as usual, which is no message at all. And then an encouraging message. Some of these problems are hard, do your best. And what we found is that the growth mindset message actually did increase how people solve problems. And in fact, encouraging messages weren't any better than no message at all. So it was really bringing that psychological theory that made a difference. Even though this is a very small effect, this kind of experiment then led people at Khan Academy to decide to run a campaign where they recorded videos and send them out to millions of learners, getting them to believe that they could learn anything, and to invite other researchers to run similar experiments. How could we maybe get bigger effects by getting people not just motivated, but reflecting as well? So here I looked at how we could ask people questions that would help them construct knowledge. And so I drew my work in my dissertation in psychology that asking people to explain why helped them learn by driving them to find patterns. And so this experiment looked at people learning statistics, where you give them a scenario, a problem, and they'd be told the correct answer. And it either be prompted, explain why this answer is correct, or write any thoughts you have about this answer. Now, both of these require elaboration, and you might predict they'd be equally effective. But in fact, this one I hypothesize would be better because explaining why would actually drive people to understand why that answer was the instance of a general principle or pattern. And that would then give them a basis for generalizing to new problems. And so to measure learning, we administer a pre-test and a post-test. And here are the results. This is accuracy increase from pre to post based on whether people solve problems with a right thoughts prompt or an explain prompt. So what you can see is that learning is significantly better when people are prompted to explain. Learners reported that it really helped them understand the logic behind it, so you're more able to solve similar problems. Both of these are important contributions to how we plug into edX, into Canvas, motivational messages, or prompts to help people reflect. But how can we push more towards that vision I outlined earlier, where we're running experiments that keep adding new conditions and then dynamically adapt based on data? And so for that application, I'm going to focus on how do we adapt the explanations that students are given for why answers are correct. And this is the adaptive explanation improvement system. So the kind of key idea here is that we want to give students explanations to help them learn. But we have an issue. A lot of MOOC instructors don't even really have that much time to write explanations. So how are you going to convince them to write multiple explanations to run in an experiment? So here's a hint. Where are we going to get those explanations from? Yeah. And why would learners be motivated to give you explanations? They're not being paid to do this. Well, in fact, if you prompt learners to explain because it's going to help them learn, they're doing it from a self-interested perspective. But then their explanations could be useful for future people. Now, we don't know if the explanations are actually, this gives us a way to keep adding new conditions, but we don't know if those explanations are actually going to be helpful for future learners. So this is why we need to run an experiment where we're going to analyze data and see which explanations future learners find helpful, and then help those rise to the top. So what learners would see would be they'd see a problem, they'd be told the correct answer, and then they'd be given an explanation for why that answer is correct. And this will come from our current pool. Then they'd be asked to rate how helpful was the information for their learning on a scale from 0, totally unhelpful, to 10, extremely helpful. And this is a subjective rating, but it does give us a lot of information. Then they'd be told to help you learn, explain in your own words why the answer is correct. And if the explanation was longer than 60 characters, and they checked the box to say it would be helpful to other people, we added this to our pool. So now, to run this dynamic experiment, I applied some algorithms to machine learning that come from reinforcement learning. And the kind of key idea here is that we're going to think about trying to trade off in an experiment, testing out explanations until we see whether they've got high ratings or not, against giving explanations that seem to be good to everyone. So this is called exploration. And so this model formally is, you've got a set of actions, and these, in this case, they're different explanations. Then you've got a reward, which is basically what are you trying to optimize for? What are you trying to maximize? And in this case, it's people's ratings of how helpful explanations were. Talk about this because this is subjective rating. It might be nicer to actually look at whether people who get an explanation do well on a future problem. But when I looked at that data, it was actually very noisy because learning depends on many other factors. And so we actually found that optimizing first for ratings got explanations that we can then show help learning in the future. So we need a policy for deciding for any given learner which explanation do we give them. In this case, I'm going to use a randomized probability matching algorithm called Thompson sampling. And the kind of key idea is you can think about this as basically weighted randomization. So you've got multiple explanations with different probabilities of assigning them. Now, to decide which explanations to show, Thompson sampling can be conceptualized as the probability of assigning a learner to an explanation is the probability that that's the best explanation given the model you have and the data you've seen so far. So the model we assume here, and I can give you an intuition, but just for people technical, it's a beta distribution where we assume that every explanation, the probability of it being rated helpful follows a beta distribution with the priors of 19 and 1. And the likelihood or the rating people give follows a binomial distribution with 10 samples, and the success parameter is basically that probability of an explanation being rated as helpful. But the kind of key idea here is that every time someone gives an explanation rating like 8, it's as if they give you 8 thumbs up and 2 thumbs down. And so whenever we get an explanation, a rating of an explanation, we're going to use Bayesian inference to update our estimate of what the true rating is. And so then we've got all these estimates of what the rating of different explanations are, how sure we are in them, and we use that to compute the probability that an explanation is the highest rated. And that probability, let's say it's 70%, is actually the probability assigned to the next person. So what you've got is that we deployed this with 150 people, online crowd workers, and intentionally chose a small number, because that means that this method could work for on-campus courses. It could work for one large undergrad course, or maybe a K-12 middle school math class offered a couple times. And so at first, there are no explanations in the system. But then over time, people contribute and they get added. And as the people are giving ratings about which explanations are helpful, the algorithm is slowly updating the estimated probability. And so what you end up with at the end is basically a probability distribution over different explanations. It's not what you might predict, which is there's just one explanation that's the best. The way the system succeeds is actually by having something more graded, where there are a few explanations that have pretty high probability and others that have very low probability because they're getting low ratings. So this system can certainly produce explanations that people rate as helpful, but how do we know if it's actually going to help students learn? So I ran a separate experiment where in one condition, we just gave students the problems with no explanations at all, kind of the default state if no one had had time to write explanations. Then in another condition, learners received the problems with an explanation that came from the access system that was filtered out, selected. Now, we also gave learners problems with explanations from access that were filtered out. So these explanations access gave less than 5% probability to. And as a gold standard, I want to know, well, how much is learning from problems with access explanations compared to learning from problems with an explanation written by the actual instructor? And so what you're seeing here is accuracy increase from pre-test to post-test. So you do a pre-test, then you solve problems in each of these 4 conditions, and then you go post-test. And so we're measuring basically how much is learning increased from pre to post. So receiving access explanations led to significantly better learning than just receiving the original problems, even though these explanations are just coming from learners who are generating it for their own purposes. We're able to kind of choose effective explanation. If you're skeptical, you might say, well, of course that's true. This is an explanation, that's no explanation. If you could give them any explanation, it'll work fine. But that's why we have this control. These are explanations that were filtered out by access. They don't get high probability. And what you can see is that these explanations aren't any better than no explanation at all. So if let's look at the final condition, the instructor's explanations. How good would access have to be compared to an instructor for it to be worth your while to use this? Is it 20% as good, 50% as good? In fact, there's no significant difference in learning from an explanation that's written by an instructor and learning from an explanation that was selected by access. I'm sure there are cases where instructors can write better explanations, and maybe even where learner explanations are going to be better. But that's kind of the direction of future research. The instructor even found that the access explanations look quite comparable to their own. So the key contributions of this work then are, how do we actually crowdsource, get learners themselves to give us content, like explanations, not because they're necessarily being nice, but because it's actually in their interest, because reflecting and explaining helps them learn. I showed how we can use a dynamic experiment to put data from an experiment into practice, actually make practical improvements that benefit learners. So in terms of limitation of future direction, one key idea here now is to think about how do we involve teachers into this loop. For example, in the context of edX, one thing that we may deploy with Sarah and Juliana is a system where learners might be explaining, but the teacher can actually filter through them. And maybe they give judgments about which explanations are effective or not. There are also many broader applications. This isn't restricted to just explanations. For example, if you think of forums community question answering, suppose underneath a video you ask people a question. What's the key assumption naive base? They might just answer this because it's helping them reflect. But can you see how that's actually helping you populate something like a question answer forum? You can now actually, in a separate area or in a discussion forum, have a question that then has people's explanations with it. So I want to close on one illustration of how we can use experiments to discover how to personalize. That's really just the tip of the iceberg. So this was a study where we sent out motivational emails, and so with Jake and Justin and I think Heather and Yasha with the course teams, where they wanted to get people to respond to surveys about why they dropped out of the course. So they want to optimize how people actually respond. So it's a question about course participation, and we ran a bunch of different experiments, but here's one of them. We varied whether there was just a brief intro message, like, will you please take this short survey so we can improve the course, versus one that mentioned the fact that they've been absent. So we just added this section, which was, it's been a while since you logged into the course, so we need to learn about your experience. And then it went on with text as normal. So if we look at this data in terms of response rates, so I'm showing you here in the vertical axis what portion of people actually respond to these emails. What do you predict is the difference between the brief and the mentioned absence message? Well, in fact, there's no difference at all. So at this point, you could say, well, we're done. Let's just go home. That was a waste of time. On the other hand, if you actually break this data up by low and high activity learners, so based on whether all these learners hadn't been active, but some were really low activity, they only logged in 0 or 1 day to the course, whereas some had logged in 2 days or more. What you see is that there's an interaction where the brief message is more likely responded to people who had low activity, maybe because they're more willing to read a short email. Whereas the mention absence message actually got higher response rates in people who had high activity, maybe because they want to explain why they've suddenly been inactive recently. In all then, by looking at data this way, you could actually increase response rates by about 14.5%, or you get 14.5% more responses if you do this kind of personalization. If you send brief to people with low activity and mention absence to people with high activity. And so I think this is just one illustration of how whenever we start experimenting, we actually have the capacity to discover what's working for different subgroups of people. But especially if we build infrastructure like the Mooklets we've developed, you can actually roll this out in real time. So you might start experimenting and then try and choose the best, or start experimenting, then actually start tailoring or personalizing, where you could send different emails to different people, or provide different explanations to different levels of knowledge. And this is going to be a big direction for me in the future, especially because I think sending emails to people in MOOCs or on campus is a really easy avenue for doing things like getting them to log into courses, send them information about study habits, or sending them links to resources that they might find helpful, like prompts for them to plan. And what's nice is you've got a lot of contextual data. In the edX MOOC, you've got lots of information about learner demographics, about activity in the course, about the reasons they're taking the course on a pre-course survey. And at NUS on campus, we've got a lot of rich contextual data about what people have been doing in learning management systems, as you would have at like Canvas. So in terms of future directions, what I'm really excited about is how do we actually now start using experiments as a way to bridge designers, social behavioral scientists, and machine learning researchers? I'm going to look more at applications like how do we build web apps or do nudges that are going to help people, like students, set goals and use effective study strategies. And finally, trying to push out more of this infrastructure in terms of Mooklets so that it's not just something that I'm using, but actually other people are able to plug and play this. If you want to run an experiment, if you want to personalize, they're end user tools that you can use. So I really see experiments as a bridge. They're very simple, but they're actually almost like a common language between a designer, like course teams or instructors, a social behavioral scientist, like a psychologist who's paid every day to test hypotheses about how people learn, and they normally run experiments in a lab. And in fact, machine learning researchers, who often, especially in reinforcement learning, they have to develop algorithms that will let you test out a bunch of alternatives and conditions and figure out which ones are most effective or what's effective for different people. So one step towards collaborative dynamic experimentation that sort of began at Harvard has been trying to integrate instructors with scientists. So we built an app for Canvas where, and here's a URL, so you can actually, if you go to Time.cc CDE site, it actually shows your website. It's an LTI tool you can install into your course in Canvas, and actually it also works in edX. But the kind of key idea here is that instructors build a quiz, and then we kind of co-design experiments on the feedback messages or on the explanations. So instructor and researcher have a very concrete conversation about what they want to test, and the researcher might bring in some ideas from psychology about what kind of explanations are helpful, and the instructor is able to use their practical knowledge. So one example might be even something simple like, is it enough to just give students an answer? Should you give them a hint, or should you write out a full solution? Here's one example from a public policy course where, for a question on statistical power, the instructor wrote a quantitative explanation that talked about normal distributions. This is an analogical explanation that talked about how statistical power of a test is kind of like having a telescope. So what we actually end up here is we did optimize just based on student rating. So not learning gains, kind of like an axis, but this is our kind of first step to see which of these explanations the student's rating is more helpful. So what's interesting is I also asked instructors to rate which conditions they expect to be affected, so they could kind of think it through and then compare that to what they actually found. So the instructor actually predicted that the standard quantitative explanation would be better or better received by students than the analogical one. In fact, it is inclusive, but it seems to be the opposite, 7.2 versus 7.4. So this was kind of an insight for them in terms of there are things that you think are so obvious, but once you test them, it can actually turn out differently. And what you can see here is that because we use this dynamic experimentation algorithm, over time, we went from 50-50 to basically about 23% of people getting that explanation and 77% getting the other one. So it's slowly, as we get more and more evidence, pushing in the best one. But it's still always experimenting a bit, because it could be that this is a blip in data. Or it could be that if you collect more data, you figure out that there's some students who are learning more from quantitative and some from the analogical. So you really want to hedge your bets in terms of exploring as well as trying to rule out the best. And for me, this is kind of a key part of making experiments more ethical and actually practical, so they're putting data into practice. There's a wide range of things you could do. For example, in a calculus problem, where we actually want to look at learning gains, we compare a feedback message, just being told it's correct, with actual feedback and a prompt to review. So this is more general. They're told, if you want to review this problem further, kind of question further, look back at your notes about where you found the function when G was greatest and least, or you can look at the relevant video and you provide a link for them to pop back out. So again, it's not just about explanations. You can actually do some pretty sophisticated things in that little piece of text that you've got after someone enters an answer. So here what we did was actually look at learning gains, where the instructor first ran an experiment where we just looked at which feedback messages were rated as helpful, but that kind of got them off the ground. And then the second time around, they actually designed some problems that students would see a problem, get feedback messages, and then they'd actually get subsequent similar problems, and we could see if the messages actually helped learning. And so here, the data wasn't that clear-cut. It seemed actually that there may be a trend towards learning, but at least statistically, we're not justified in being sure that there's a difference. And so in this kind of context, the instructor found this helpful because, one, just going through the experiment got them to reflect, but it's providing them with some evidence that they may be on the right track. But then they can now actually just deploy this again in their course next year. And they felt confident they could keep this running, and eventually as we get data, it's going to roll out the best. And I guess the key idea here is that you might start off having people optimize for something like student rating of feedback, but then we can sort of start to incorporate measures like learning gains. So in terms of qualitative instructor feedback, they felt that there's lower barriers. So I'm not aware of any tools that do this sort of thing. And even if I found one, I don't think I'd have the technical expertise to incorporate it. It also helped them reflect on pedagogy. I've never really seriously considered typing in multiple versions as we're doing now. So even if we don't get any significant data, that'll be a benefit in my mind. So just the act of trying to design an experiment can actually help you think through pedagogical decisions. They also like that it made research practical. So it puts it in the hands of the teacher to understand how their students learn, not just in broad terms, but specifically in their course. And they also found it valuable to interact with the research in this more concrete setting, where you must know kind of general things about how students learn, whereas I know specific things about how they get calculus. And that was a useful synergy. And then finally, they really appreciated that it directly could help students. It wasn't just an experiment for experiment's sake. It actually can improve the experience of many students by giving them answers that are more helpful. So the earlier ones can help improve the experience of the later students. So that was pretty neat. So another kind of key direction for me is to think about how we can segue a lot of these experiments on feedback messages, motivational messages, and prompts to reflect into teaching generalizable skills. For example, everyone's got to set goals. and figure out when they're going to work on different assignments across different courses. And so one thing I'm starting to look at is basically a web app that would actually, you could email links to people, and when it pops open, it would prompt them with questions like, what are you trying to get done by tomorrow? What are the obstacles to achieving that? Should you redefine your goals so that you're more likely to get it? Are there other priorities you might have? So the kind of key idea is having this kind of app where we're going to run a range of experiments on which kind of prompts work for different people. And this is a setting where I think we're especially going to need to tailor and personalize, because especially in planning, where some people like particular regimented schedules, some people like something that's more open-ended. This is a setting where I think being able to discover what's really different people would be especially important. Exactly. Yes, that's exactly right. And another direction I'm looking at is actually student study strategies. So I showed that prompting people to reflect help learning. But how can you actually get students to ask themselves these questions at any point in time? So this is something I developed at Stanford, but I haven't actually deployed in the course. It's a little module on what I was calling the reflective question strategy. So it's saying to students, well, you can actually try to be more active by asking yourself a set of questions while you're watching a video, before you're reading a text, or after you're done an activity. And so in addition to having that module that tells them what to do, there's also this kind of interactive web app. They can just go to this URL, tiny.cc/RQS. I guess a lot of people know I'm a big fan of tiny.cc. But you can use anything. The key idea here is that it's just a link. Like you just have to think a thought, you type into your phone or your web browser, and it just pops you into a Canvas course or a MOOC. And then there's actually this web app. So then it asks them questions, and they can choose. Are you about to read some text? Are you reading text right now? Or have you already finished? Here's some questions you can ask yourself. So the kind of idea here is then figuring out how do we get students using these kinds of tools, and is this actually going to help them ask questions that will get them to reflect more? So if anyone's interested in testing out this kind of thing in courses, I'm definitely open to this. And so now the third sort of kind of key direction I'm excited about is, this MOOClet software requirement spec. It's almost a pity that when I say MOOClet, it sounds like one thing. But really, it's a sort of concept which is kind of saying, well, here's a new way of doing experiments. So you can keep adding conditions, you can analyze them, you can adapt. And it's kind of the software infrastructure for it. But there are many different directions to go in here. For example, there are API endpoints so that people who do machine learning can plug it in. But it can also be a backend for something like, how would you as an instructor be able to review other people's experiments and deploy them into your course? How can you be sure that you get the data you care about, but when you collaborate with an external researcher, they're not getting things that are private or confidential? Those are the kind of issues we're thinking about now. And just so people on the technical side, the kind of key idea of the MOOClet is basically you've got to learn a resource. And so it's actually, if you've heard me talk about before, it's kind of a general concept, but now it's a very specific set of software requirements. So a resource like an explanation or a motivational message or an email, all those things you saw me present, that's a MOOClet if and only if the backend is set up so that there's a set of versions, so a data structure that holds different explanations that can be modified by an API call. So you can add them in dynamically, or you have an interface for adding it. If that's distinct from the policy, so the policy is the method of presenting it. Random assignment is one policy, and that's what edX's tool does. It only does random assignment. They have A/B testing. But the key thing here is that you can actually change that policy. You might start off A/B testing, but then you might want to switch to actually saying 80% of people get one thing, 20% get another. Or you might want to personalize. If you've got low knowledge, then you get this. If you've got high knowledge, then you get this. And you can actually change all this at time. So this is where different machine learning algorithms can be plugged in by API. And then finally, there's also a limit data store. So the way I've been implementing this is that there's data in edX or Canvas, and then there's a separate data structure where you can send information via API. So that this is things like people's ratings, their accuracy on subsequent problems, contextual data, like what courses they've taken before. And the kind of key idea here is this is just a really flexible way of doing experiments or adaptivity, where any policy can access anything that's here, and you don't know yet what you're going to use. You might start off optimizing for ratings, but maybe down the road you actually find out that you want to optimize for a quiz a week later. Well, the nice thing is you can push that in via API, and then policies can start consuming it. So this is more like a specification for if someone's implementing experiments, this is something they could follow. Like I wish I was there when edX was doing experiments. I guess MOOClets didn't exist then, but I wish I was there because then the tool could have been a lot more flexible. And another kind of big direction also is thinking about adaptive personalization. If you're someone who works on like the course that Colin and Ilya and Andrew worked on, when you roll out those different versions, different problems, how do you recommend them? Well, you can have some specific custom code that uses Bayesian knowledge tracing. But if you use something like a mooklet, what's nice is that your policy is actually distinct from your representation of versions. What that means is you can actually swap these in and out. It could be Bayesian knowledge tracing, or it could be some other algorithm. And then the learner data store, instead of that being in some code that's written on Microsoft Server or Harvard Server, there's some parts of that you could expose via API so that you can push data to two places, and then you don't have to give someone access to your full database. There's certain things you can push and let them access in secure ways that they can then actually test out and see how different algorithms would work. This is going to be especially important, and this is a bit underspecified. How do we set this up so that instructors get one view onto data and researchers get another? So that machine learning researchers see something different from what psychologists care about. And this is something that's been done a lot in public health, where you can actually let people run analyses on data without actually ever giving them the data itself. So in terms of where it's been deployed, so it depends how you think about it, but it's been used for those motivational emails for explanations in that access system in the context of Canvas. But also, technically, all the pre-course surveys are doing random assignment using something like this. And we actually rolled this out in the edX course, this Caltech one, where the mooklet was actually which prompts people would get on the discussion forum. And so there's backend code here, Andrew, Sam, and I, with like a mooklet class. And then you can actually, a really nice feature of Django that Andrew helped us set up is you can actually go and declare mooklets and play around with them. You know, you could say, well, what is it like to see different versions? You know, how do I see set variables and see what the policies are that you use to deliver? And I think this is great as a test bed for reinforcement learning. So on Tuesday, I went to a conference called Reinforcement Learning Decision Making. There are these great researchers who are developing algorithms, but they only ever test them on simulated data. It's very rare to actually use your algorithm to trade off, you know, testing out experimental conditions and rolling out the best. It's extremely rare to do that in real time on a real data set. But to push that kind of field forward, you really do need a test bed, right? You need to sort of provide people with a tool so they can actually see how these algorithms perform on real problems, how they face real-time issues like data being noisy, information coming in slowly, having multiple objectives you've got to optimize for. And this basically provides APIs for machine learning researchers to do that. Another kind of key direction here, I think, will be making machine learning more interpretable. So there are many algorithms for dynamic experimentation. Some, like upper confidence bound, arguably structures. So the ones I presented, actually, you can always understand what the algorithm is doing as basically weighted randomization. Another direction is interactive machine learning. Algorithms are great for being automatic and scalable, but to be honest, to solve problems like education, you've actually got to bring people into the loop. How could we help course teams play a role in figuring out how much a system should explore explanations versus choose the best? Or could we actually encode prior knowledge in terms of which conditions people expect to be most effective? You don't have to start 50-50. You can start 20-80 if you think one condition is better than another. That gives you best Bayesian inference, which is if you're right, we get to the solution quicker. But if you're wrong, you still get enough data that you learn that. All right, so in conclusion then, I started this vision of perpetually improving systems. How can we deploy any resource, whether it's a problem or lesson, in a way that we could then keep improving it over time? And my approach to that is to sort of build technology for making experimentation collaborative, dynamic, and personalized. I give two examples of collaborative experiments between psychologists and instructional designers in Khan Academy with motivational messages on a growth mindset, actually increasing motivation, and also with different questions, different prompts that people explain why, being more effective for learning from math problems. I presented one system, the Adaptive Explanation Improvement System, that was able to collect crowdsourced explanations from learners and run a dynamic experiment that actually produced explanations that helped learning as much as those of a real instructor. I gave one illustration of how we could run experiments and try and discover how to personalize, where we could find different conditions, different motivation emails work well for people with different levels of activity. And I already close on what I think is most exciting about this, which is the future work. How can we kind of take this approach, this rethinking of experimentation, and use it as a way to bridge instructors, social behavioral scientists, and machine learning researchers? How can we actually start applying it more broadly, like apps that will teach people general skills, like how to set goals or how to ask themselves reflective questions and study more effectively? I think the kind of key to that is going to be thinking through how we extend out this infrastructure like mooklets, which kind of help us to experimentation in more flexible ways, and also to adaptive personalization. And again, I'll be at NUS, and I'm really happy to talk to anyone who's interested in chatting anytime. And in general, in the future, I'm going to be as an external collaborator. So I'm looking at VPAR research. So what this means is VPAR research has limited capacity for what they can do. They're serving the whole university. But if there are questions you think might be interesting, you think practically interesting, you'd like to have research to work on, feel free to email me and CC Igal, because I will be collaborating. I'm just going to sort of work with Igal as like my point of contact for VPAR research, and maybe there are MOOC projects or on-campus projects that would be interesting. All right, well, thanks so much for your attention.
Questions?
Yeah, for sure, please.
So I actually have a quick question. I know the population who takes MOOCs is actually very gender biased, so very 70. So by using these sort of tools to figure out what makes an explanation better, we're biasing every single thing that we're doing against this population. Are we planning on doing anything for those principles? Because otherwise it's just completely biased. Every single thing we do is biased in some way based on the population. We'll be gender biased. Will be biased for younger people because the average age is 74.
Yeah, I think that's a great point. So I guess I'm taking the question as, how do we deal with the fact that when we're trying to discover what works best for people, there may be underlying biases in the people we're sampling from. And in fact, we might rule out things that aren't helpful, that look good on average, but actually are bad for some subgroups of people. And so I think this is a great argument for why we should be running these experiments in kind of flexible ways. Because right now we just sort of put one design up. We don't even have the option to test different alternatives. Whereas if we run experiments, we can actually try to discover what's working for different people. And I think what you're saying there would be a really good argument for basically experimenting a bit longer. So I think one concern instructors might have is that they start experimenting and they see, well, actually, it looks like this is bad on average. Or like, it's leading to 60% learning versus 50. And so they might say, well, let's give it to everyone. On the other hand, that could be problematic for exactly what you said. 60% better than 50 on average might actually be because, let's say men are learning more from one particular setting, whereas actually women are learning more from another. So that's...
I was looking, you gave an analogical explanation for one of these problems.
Yes.
If you use a sports analogy and you know what that sport is, all of a sudden that is...
Yeah.
And then with that kind of leads into the second question. Do you have any opportunities for learners to say this was useless for you? I have another explanation.
Okay, great. So that's actually a great point, which is when we run experiments, we don't have to give people just one condition. We could actually let them essentially say, I want to be an experiment again. So they request a second explanation, then they get randomized again. And so I think that's a great point from an ethical point of view, which is then they can see the different conditions. It's good from a learner point of view because they feel like they're getting something useful. But actually, from a statistics and research point of view, it can also be useful. You have to do some more sophisticated statistics. But it's called like a repeated measures or within subjects design, where sometimes seeing how Shilpa rated explanation 1 and 2 will give me different information than seeing how Shilpa rated 1 and Maggie rated 2. So that's actually, again, information that's kind of grist for the mill in terms of figuring out what's working well. So that's something I'm definitely very interested in. Any other comments or feedback or questions people have? How would you guys use this? Or what do you find, what's most exciting about this? Or what are the concerns you can anticipate people having? What would you like to see me do with this? Yes, Sarah? Okay, thanks a lot. Yep, exactly. That's definitely true. Yeah, the graph. Mm-hmm. So you kind of like the email direction, but you maybe a really nice direction to push it in would be how to use email more in a conversational way, where like you send people a link, they might click on something and they can like send a message back, but then it's easy for you to kind of respond to them. Kind of like a more lightweight focus group or something like this. Yeah, I think that's a nice thing to think about.
I have another question. Why 11.5 grade scale? Why not something a little bit simpler? Learners at that point when you've got 11-point scale, 7th grade, you just got to scale.
Yeah, so I think this is a good point. It's a very controversial topic actually, because certainly it feels a bit nicer to make these smaller judgments. So the argument is like simplicity. People might prefer a smaller scale. Maybe you get better data, and that is true sometimes. The other issue though is that when people are doing like 1, 2, 3, 4, 5, there's not much difference between 4 and 3. Whereas when, for example, okay, so let's say I
would go Netflix style and just thumbs up, thumbs down.
Yeah, the thing is, so that's definitely easier, but then use a lot of data. You really do lose a lot. Whereas when you use some 10-point scale, okay, actually, let me give you a funny example. Shilpa, how much do you want to go to the gym with me today? Yeah, thumbs down. But Shilpa's very direct. Some people will be like, well, waffle. When you ask about Shilpa on a scale from 0 to 10, how much do you want to go to the gym? When she says 6, you know she absolutely does not want to go. But it allows you to say something that you wouldn't have said otherwise. So whereas when it's thumbs up, thumbs down, either you don't respond at all, it's a very rough judgment. Whereas I think these gradations sometimes let people communicate more sensitive information. But it is a controversial topic, and like people argue back and forth all the time.
Something that I found going into your assessment rubrics and stuff like that is oftentimes the more options that you give them in the rubric, the less they're like actually doing it. And the more they complain about how much effort.
Yeah, it is a trade-off. And I mean, one thing to just think about there is like the trade-off between who's going to spend. I guess there's two things. One is how much do we trust like subjective, I don't like doing this. Because sometimes, I mean, maybe here's an interesting issue. User experience is very different from like user benefit. Like, and maybe people don't like doing it that much, but it's actually kind of helping them. Or for example, one thing the instructor said was like looking at this rating scale, she said, well, you know, I wonder if that's actually getting learners to reflect more on the explanation. Because if they just had the explanation, they may not even read it or they might skim it. But when they have to think, well, how helpful was this? They've actually got to read and process it. So, but again, I think that's sort of always a tension is sometimes learners have a sense of what's actually helping them, sometimes they don't. Yeah. Sure, yeah.
So is there kind of a trade-off or like a balance of feeling like survey throughout the course and like when how do you judge that?
Yeah, that's a great question. It's a really broad one. I'm not sure if I can answer it in general, but here's my slant on it. I would try to kind of embed those questions in places where it feels natural. So the one thing that about the prompt, how helpful was this explanation, is that it was kind of nice because it felt natural to learners. I just read it. Oh, let me give a judgment. You know, so I wonder, you know, maybe there are ways to collect feedback that are a bit more embedded into the course. Like after you finish a video, you know, how helpful was this video, or was there anything you change? And then maybe kind of like what Shilpa said, if they give a low rating, then you have an option to be like, if you can find the video that helpful, here's a problem you might like. Or here's how someone else explained what it was about. So I think trying to make it feel like they get something out of providing this information, you know? Any other questions or suggestions or comments? Well, yeah, please. I mean, it's been really great being here, and I've really enjoyed it a lot. So please feel free to reach out anytime. Thanks. Anyone wondered whether these taste kind of like donuts?